I'm Julian. I'm a lecturer here in our computer science programs. So I'd like to talk a little bit about those. Right, so you come to an open day, you're looking at degree programs, and it's difficult to choose between the degree programs, and there's often a bewildering range of options. And I'm afraid we're guilty of this in computer science as well. We offer computer science, software engineering, as well as some specialist pathways in those. So I'll spend a minute or two talking about what the difference between those is to help you get an understanding of why we offer those. So computer science is what we think of as our flagship program. It's the core of our business. And, if you want to come and study computer science in Southampton, there's a degree to the program for you. Why do we offer the other ones? Software engineering is a more specialist program. It's very similar to computer science in a way. The first 2 years are entirely the same. Okay? But what software engineering allows you to do is as you move into the 3rd year, and perhaps the 4th year, if you're on the MN program, is to focus more on modules which talk about the business of producing software, the activity of writing programs. Computer science, on the other hand, is a wider discipline. It talks about computation as a phenomenon and everything that surrounds that, and it's not simply about how to write programs. And so there's more options and wider range of courses available to you on computer science. If you're interested particularly in writing programs and want that to be your degree title, and you want that to show to prospective employers, then that's a good option for you there. Okay, so this is why we offer both. But if you're thinking, I don't know what to choose, then computer science would be a fine choice, and it gives you that flexibility. There's always the chance to switch between them if at a later date you choose as well. So saying that, we also offer the specialist programs in artificial intelligence and cyber security. Again, so that's they follow the computer science curriculum, but at a certain point we ask you to take particular options so that we can badge your degree and say this you have specialised in this discipline is a way of showing that to future employers. The other factor with that is that when you come to a 3rd year project in this discipline, if you're in a specialised subject, you'd be expected to do a project appropriate to that specialism. Okay. And we provide the supervisory support for that special subject. So, why computer science at Southampton though? What's special about us? Well, if you look around the country at the different computer science programs, you'll see some places that offer really quite theoretical programs that pride themselves on being very academic and very theoretical and very rigorous, and you'll get a good solid grounding in computer science. That's true, but on the other hand, you see some degree programs which are very vocational or sort of practically oriented in that will emphasise the programming and development side of things. We like to think that we sit in a happy medium between the two. So while we're very keen to study the more theoretical aspects of the discipline, I mean, it's a very old discipline, computer science in lots of ways, and then we look at the scientific aspects that go into computation and go into programming. At the same time, we say, well, we want students to be to have practical skills. We want them to be able to write decent code, and so we're not going to ignore that either part of it. So we do a mix in our programs, and as a result of that, our graduates are highly employable. They're sought after by employers because they have this nice mix of the practical skills, but also the rigorous underpinning that you need to go along with that. It's all very well learning a particular modern programming language. That's going to change in a few years' time, and you want to know that the students are good enough to adapt to that. If you've got the underpinnings, they'll be able to. So we have a good high employment rates out of these programs, exactly for this reason. We have, when you hit the 3rd and 4th years in the programs, you start specialising you have a choice optionality in your program where you can start choosing more specialist topics. So you follow your interests at that point, and you'll see when we look at the structure, there's a wide range of these. We're a very large department here. A consequence of being large is that we have the ability to offer a very wide range of optional modules. That's not something you necessarily see in smaller departments, so the students benefit from the scale at that point. We're a research-led department, so we're active researchers, and all the research we do, we get very excited about, and we want to tell people about, so we feed that back into the teaching. So we refresh our modules, especially in the third and fourth. We refresh these modules and try and bring the students up to the level of what we're doing at the research. So I'll talk a little bit about the structure of the computer science program. Like I said, software engineering follows the same pattern for the first 2 years as well, as they do the other specialisms. So you see straight away, I've broken those into two sets of four. That reflects each semester we're teaching. So you see straight away then that mix of theoretical and practical. So mathematics 1, programming 1. We have a theoretical module, a practical module sitting alongside each other. Why mathematics? Aren't we here to study computer science? Yes, but mathematics is fundamental to computer science. To study computer science rigorously, in a serious way, we need a way of talking about certain concepts. And mathematics turns out to be sort of the lingua franca of computer science. So we encourage all the students to take that. As well as that, we follow that up with Mathematics 2 in the second semester, where we'll learn a certain amount of mathematical techniques that feed into more specialty topics later on. So things like linear algebra are absolutely essential for understanding machine learning, so we'll cover the basics of that here. Programming 1 and Programming 2, this is a year-long programming course in which we'll lead you from sort of low-level imperative programming through to object-oriented programming, and then essentially, by the end of the year, you'll be able to build a standalone application with all sorts of features like, the graphical interfaces, networking features, multi-threading, that sort of thing. So the idea is to get you to the point where you can build an application right in the very first year. As well as that, we have various other modules which talk about system stuff. So we've seen David talked about the computer engineering degree, saying we shouldn't be ignorant of these machines that we're working on. We should know about what's going on there. We don't ignore that in computer science either. We pay attention to that, and we cover modules in that sort of thing. There's less emphasis in that on the computer science program as there would be in engineering, but you still get exposed to that sort of thing. What else? And so we cover modules in networks and security, that's what it says on the tin. And algorithmics is a more theoretically oriented module which talks about computation problems and the difficulty of those, independently of any way of programming. The second year, this is all the modules on this are compulsory, so there's no optionality here, and then it's shared between the programs. And again, you see that mix of theory and practice in there. We move to larger scale software applications, so not just building an application on your own, but now you're looking at large software projects in teams of people. And we set projects in groups to give students problems that they have to solve as a team, and all the difficulties that come along with that. And we give them design principles to help that. Theory of computing, of course, then is a theoretical model which looks at underpinnings of language and automata theory and stuff like that. Programming 3, we shift away from what you've learned in the first year in the more traditional programming sense and move to a new programming paradigm, new to a lot of you at least, called functional programming, where we change the way we think about what a program looks like, change the way we solve the problems, and work in an entirely new language with the idea of helping us become better programmers in the general sense. It gives us another tool in the toolbox when we come to a new problem. Looking at that, we also look at things like formal specification of languages, of programs. When you're building a large project, it's very important to specify exactly what that should do so that everything doesn't get lost in communication. We show you the tools and techniques for allowing that sort of thing. And again, also we return back to the hardware there in Computer Systems 2. It's a great module where we give you a bare bones device. You don't have to build the device like you're in computer engineering, but you then have to build the operating system that would run on that device and get that up to application level. So we give an exposure again to that hardware. And also we don't ignore artificial intelligence. We're foolish too. Okay, we see this we cover aspects of that in the second year already, which you then can opt into modules on that in the third year if you find that particularly interesting. I won't say too much about the third and fourth year because they're much further in the future. But just to say that we're on computer science friends, we do the third year projects, that's 3 modules worth. That's an individual project where essentially it's a topic of your choosing. You can choose whatever you like as long as it fits within your discipline. If you're a cybersecurity student, we expect you to do something related to cybersecurity, computer science, anything in computer science is fair game. And we do see that range of options. Again, because we're a large department, we can support such a wide range of possibilities there. As whatever crazy idea you come up with, you've probably got a supervisor who's willing to supervise that and knows something about it. So alongside your project, there's a wide range of option models, and you can see from the titles of those how you then start specialising in particular areas. So the first and second year are quite general core topics, and we're specialising in topics now, obviously. Fourth year, we have the group design project. This is the project in the main MEng programme that you have. Where you form a group of students and you get an industrial partner who set the problem for you, and then as a group you're expected to solve that problem and deliver a product for them. It turns out some very exciting work comes out of that. Okay, you get to show off all the skills you've been developing over 3 years. And again, there's a wide range of options to choose from here, and these really start pushing towards research level in these options. And that's one of the benefits of doing the MEng programme, is that you get to take on these more advanced topics. So I've talked about the academic side of things there, and the particular courses, but actually what a lot of people come to us on the open days and ask us about is non-academic questions. So the next few slides talk a bit about the sorts of things we get asked, and hopefully we can anticipate some of your questions there. So a very common thing that we get asked about is work placements whilst you're studying. So we would say that there's 3 typical pathways in which students have some work experience during their studies. One would be to actually sign on for the MEng programme with industrial studies. So this is a formal programme we offer, where coded into that programme is a year in industry. Okay, so you typically do 3 years of study, suspend your studies for a while, and then do your year in industry, then return to study in that 5th year. So why would you do that? Well, if you're interested in the work placement, it's a good option to do that. You earn money while you're studying in a way. But one of the benefits of doing this as part of an official programme with us is that you're still under our wing. Okay? So we keep liaising with you throughout that year whilst you're in an industrial placement. So we have a specific academic who looks after everyone who's on an industrial placement and has regular communication with them to make sure things are going well. And there's also a small amount of assessment we ask you to do at the end of the year in the form of a report, just to kind of make sure that you stay in the world of academia and think about studying. So an alternative way of doing the same thing in a way is to say, well, I can do that myself. I can just sign on for a programme, suspend my study. Well, technically you're requesting to suspend your study. It's not automatically guaranteed, but I've never seen it turned down. But you would suspend your study and then take a year in industry and then come back when you're ready. This way of doing things, because you're not formally on the programme doing that, then you don't have that support, you don't have that liaison. Whereas you suspend your study and you go off a year, you're on your own at that point. Okay, so a slightly different approach to it. Okay, but you would still technically be one of our students. You'd still be on the books. You'd just be suspended. Suspended. Another way of getting some work experience is to do a summer placement, and this is by far the most common approach. Is students use the summer. The break, usually the summer between their 2nd and 3rd year, to do a work placement, which would be paid work for several weeks in that summer, often with a company who's interested in sort of sponsoring or taking them on later, and quite often that work placement will turn into a project for students in the 3rd year. So that can work very well. Okay. Employability. Our students, like I said, our students are very employable. We're in a fortunate position in ECS, in that not only do we have access to the University Career Service, in ECS itself, just in electronics itself, we have our own career service. So we have a full-time role of a person whose role it is to liaise with companies and to find placements for students, to get them into and have dialogue with companies in a way that and create that interaction. It's really, really useful for us. We've got over 300 companies that we're regularly in communication with. They come to the university. We have a careers fair where they set up desks and talk to our students and talk about the opportunities. They host events. They do guest lectures. They have events in the labs where they sponsor prizes for hackathons and things like that. So there's lots of nice communication with industrial partners, and you can see that the store has a big list of companies there. It's not every student's dream to kind of get the job, to kind of do the degree program and go straight into a job. Some students are much more entrepreneurially minded and want to start off their own company. They've got some great idea and they want to make that work. We've got support for that. So Future Worlds actually started in ECS. It's now been spun out to the whole university. What is this? It's a startup accelerator. So in practical terms, that means we've got space for you to, office space that you can use to start up your business. We've got mentoring programs about that. People who've already started up companies and can give you advice for that. We have mentors who come in and give guest lectures, and also we run events, networking events, and there's even like a Dragon's Den style event with real investors who you can pitch your ideas to, and they will invest in these startup companies. So this is a very successful unit, and it's free for use for any of the students or staff. And so it's just help to get businesses started. Why do we do it? It's good for the university reputation. It's good to see research getting out into the world. Scholarships, there's a range of different scholarship options. Of various eligibility. I don't know too much about them, so I won't spend long on this slide. But you can see there's different ways of getting small amounts of money to help support your study through there. One of which is related to the taster courses, which are a good thing. So the department puts on taster courses during the summer. If you attend one of those, that opens up eligibility for a scholarship there. So there's some links there that you could look at. And there's lots of degree programs have options to apply for scholarships and support. They seem very happy with what they've got there, don't they? Right. Okay. ECS is a community, right? One of the things that we really pride ourselves on is the activity that goes on here, because for all of our members, our students are all levels in and staff. How do we make sure that our students are well looked after though? We care about the welfare, we need to make sure that every student is flourishing here. It's a large school, right? And as parents, you're probably worried that, coming to such a large place, is my child going to get lost in amongst all these people? So what do we as a school help, how do we help with that? Well, every student is allocated a personal academic tutor. Okay. So what does that mean? A personal academic tutor will meet with students in groups of just 5, maybe 6 students every week. Okay, so they'll have a fixed meeting every week with just a small group, and they will talk individually to students about their progress during that week, about how things are going, whether they're keeping up with things, any questions about the course material, any concerns, not just academic concerns, it can be pastoral care as well. So you have that regular contact on quite a personal basis. So we know that your students are going to have a personal contact in the school. Beyond that, there's lots and lots of avenues for support, including a senior tutor team, which is a team of people who are just, will reply to email with all sorts of issues that students come up with. And then there's the university itself has units like the enabling services for students who have additional learning requirements, and then the student union run a big support network as well. That's run by students. So there's lots and lots of different units across the university that provide support, and then in ECS itself we have special individual support at the personal academic tutor level. Another part of support is actually students joining in with each other in a community. And so how do we support that? Well, the ECS has a lot of student-led societies. So So this is extracurricular activity, where the students just interested in a particular topic, and they just like, spend their evenings and weekends studying it or talking to each other or putting on events. So we have at least 15 societies in ECS alone. This is not, before you even look at the university-wide, where there's many, many more. Yeah. And the sorts of things they do, some of them are quite academic-minded, like the Cyber Security Society, hold regular talks on various aspects in cybersecurity. Robotics Society, build things, and there's the ECS Society itself is just a student-led thing that run hackathons and stuff like that. So there's plenty of opportunities for sort of a more social, but still rooted in academia aspect of ECS as well. Okay. If that's all sounding very good, and you think, yeah, I want to be a part of this, what do you need to do? So our typical A-level offers are A-star AA for most of the programs. I think the B-Eng in the engineering modules is 3 A's. We're looking for maths and physics on the engineering side of the school. Okay. There's some wriggle room on the physics, so depending on what else you've done instead, you can talk to us about that if you've got a slightly different scenario. But maths is a good one. We're looking for maths both in computer science and engineering. So we're looking for strong performance in maths on both sides. It's a high offer, A-star AA, it's a high offer, but it's a good target to aim for. I say you should always aim high, because the benefit of that is that your peers, when you arrive in this place, your peers will also be people who've aimed high. Your peers will all achieve these grades, which means that you're going to be among a good quality people. They're going to be interested in the discipline, lots of people to talk to and to learn with. Okay, so this it might seem daunting, but it's a good target. There is, like I mentioned, there's a little bit of flexibility in those offers, in particular with physics. And also we look at alternative qualifications, things like EPQ, and there's other various things. We do make contextual offers. What that means is we look at the context in which a student has been studying. If they're in particularly challenging circumstances, we can sometimes lower the offer to reflect the effort and the achievement they're making in those challenging circumstances. Or if, for example, you're taking more A-levels than the 3 levels, we might adapt for that as well. Okay. There's also an option to enter the programs by a foundation year. There's a desk for that in the tent with computer science. You can talk about that if maths was an issue for you or something like that. But there's alternative routes in. Okay. Lots and lots of information on the course website, and we're still around to talk to for another hour or two. So if you have any questions, you can come and see us. And then just to finish up quickly then, we're a large department. Large means lots of optional modules, lots of choice, lots of support for topics. It's a good thing. We're going to learn electronics and computer science right from the get-go. We're going to get you programming right in that very first week, or the electronic side, what we'll do there. But you're going to have the flexibility to specialise as you move through the programs. We've got really good facilities. Hopefully you've been on a lab tour already and looked at the facilities that we have. We've invested a lot of money in that, and hopefully that shows when we look around. We've got a nice balance between theory and practice in our degree programs, so we recognise the need for practical skills, but at the same time give rigorous degree programs. And what we're really trying to do is help you into an excellent career. Okay. It's a great ACS, a great place, a lovely community. It's a great place to work and hopefully to study as well. All right, let's stop there.
Thank you very much. I would like to invite the student ambassador to answer the question.